Yeah, you can start, ma'am.
Okay. Good morning. So let's start with the remaining topics of blood. That is, first let's see about the ESR, PCV, and blood indices. ESR means erythrocyte sedimentation rate. PCV means packed cell volume, and all the other blood indices. So before going to the ESR and PCV, let's see what's mean by hemolysis. Hemolysis is the destruction of formed elements. Like formed elements, we know that is the RBC, WBC, and platelets. So hemolysis is the destruction of formed element. That is the in majority cases, the EGC process which involves the breakdown of RBCs by liberating hemoglobin, and fragility is the susceptibility of RBC to hemolyze or tendency to break easily is known as fragility or fragile. RBCs are more fragile. There can be a mechanical destruction, and also there is osmotic fragility. Osmotic fragility means if the cells are exposed to hypotonic saline, and then the cells will rupture. And the mechanical destruction or mechanical fragility means when occur due to the mechanical trauma, that's wound or injury. RBCs are staged in an osmotic equilibrium. So when the osmotic equilibrium is disturbed, the cells are affected. So the RBC is immersed in a hypotonic saline. The cells will swell up and become gain fluid from saline, and the cells may rupture. In hypotonic, that's known as ghost cells. And if the cells are kept in hypertonic line, if the osmolality is more than the RBC, the cells will get shrink up. That is known as crenation. And the erythrocyte sedimentation rate means that is the rate at which the erythrocytes are settling down. That's the time duration which the erythrocytes are settling down. So when the blood is mixed with an anticoagulant and allowed to stand on a vertical tube for a period of time, the RBCs will settle down due to gravity. And there is a supernatant layer of plasma. Clear plasma will be visible. So there are two methods we can use to determine ESR, that is Vestigrand method and Winthrop method. So the normal values of ESR by Vestigrand method is in males, it is around 3 to 7 millimeter at the end of 1 hour. Means the RBCs will settle down around 3 to 7 millimeter at the end of 1 hour. And in females, it is around 5 to 9 millimeter at the end of 1 hour. And in infants, it is around 0 to 2 millimeter in 1 hour. And by Winthrop's method, in males, it is 0 to 9 millimeter in 1 hour. And in females, it is around 0 to 15 millimeter at the end of the hour. And infants, again, it is 0 to 5 millimeter at the end of an hour. And the variations, in majority cases, ESR is used for prognostic condition. More than a diagnostic value, ESR is having a prognostic value. So the first stage is age. ESR is less in children that we have seen, and also it is less in infants because of the more number of RBC. And in gender, it is more in females than in male because of the less number of RBC. And in menstruation, the ESR increases during menstruation because of loss of blood and RBCs through the menstrual fluid. And in pregnancy, from third month of to parturition, ESR increases up to 35 millimeter of in 1 hour because of the hemodilution. So in this case, we can easily say ESR, it is inversely proportional to the red blood cell count. ESR is inversely proportional to RBC count. Like if if RBC count is increasing, ESR will be decreased. In pathological condition, ESR increases in disease conditions such as tuberculosis, anemia except sickle cell anemia, malignant tumor, rheumatoid arthritis, rheumatoid fever, and liver diseases. And allergic conditions and sickle cell anemia, there is a decrease in the ESR levels will be seen. So the factors which affecting ESR are specific gravity of RBC, Rouleau formation, increase in size of the RBC. And there is a factors which decreases ESR count is viscosity of blood and RBC count. Next, coming to the packed cell volume, that is the proportion of blood occupied by RBC. That is, blood is the fluid. In that fluid, how much RBCs are present? Only RBC alone, how much it will be present. That is expressed in percentage. It is the volume of RBCs packed at the bottom of hematocrit tube when blood is centrifuged. And it is also known as hematocrit value or erythrocyte volume fraction. Hematocrit value or erythrocyte volume fraction. So why we have to determine PCV? The determining PCV helps in diagnosing and treatment of anemia, diagnosing and treatment of polycythemia, and determination of extent of dehydration and recovery from dehydration after treatment, and decision of blood transfusion. Also, the normal value of PCV in males, it is 40% to 45%, and in female, it is 38 to 42%. Like the anemic condition, we can RBCs are present. Or in polycythemia, how much, whether the RBC level is increased or decreased. And dehydration. Yes. Yeah, hello.
Ma'am, screen is not inactive.
But it is showing screen sharing.
Oh, it's something blank.
Okay, 1 second. I will share again. Is it clear now?
Yeah, fine.
Is it clear? Now the variations in PCV. The variations in PCV, that is increase in PCV is seen in polycythemia and in dehydration, And decrease in PCV is seen in anemia, liver cirrhosis, and in pregnancy. So let's see about the blood indices. The blood indices are the calculations derived from RBC count, hemoglobin content of the blood, and PCV. So the importance of blood indices. The blood indices helps in the diagnosis of the types of anemia, because by using all the RBC count and hemoglobin content and blood PCV, so we can get a proper picture of the anemia, the type of anemia. So which include mean corpuscular volume, mean corpuscular hemoglobin, mean corpuscular hemoglobin concentration, and color index. So first one is mean corpuscular volume. Mean corpuscular volume is the average volume of a single RBC, and it is expressed in cubic micron. So the volume of a single RBC, that is packed dissolved volume in ml per deciliter divided by RBC count in million. And second one is mean corpuscular hemoglobin concentration. That is the quantity or amount of hemoglobin present in one RBC, or how much hemoglobin is present in one RBC. That is expressed in microgram or pictogram. That's around 32 pictogram. That is the normal value. So by this, we can assess the hemoglobin level of an RBC. And next one is mean corpuscular hemoglobin concentration. Mean corpuscular hemoglobin concentration is the concentration of hemoglobin in one RBC. How much hemoglobin is present in one RBC is known as mean corpuscular hemoglobin concentration. So it is a hemoglobin expressed in relation to the volume of one RBC. So the unit expression is percentage, and it is the most important absolute value in the diagnosis of anemia. It is mean corpuscular hemoglobin concentration. That is the normal value is around 30%, that is around 30 to 38%. Next, coming to the color index, that is the ratio between the percentage of hemoglobin and the percentage of RBC in the blood. That is the percentage, hemoglobin percentage divided by the RBC percentage. So with this, we finish the parts related to the RBC. Now let's see about the other formed element, that is platelet. Platelet is a formed element which doesn't have a proper shape, and its diameter is from 2 to 4 micron, and volume is around 7.5 cubic micron, that is around 7 to 8 cubic microns. And it's having a different variety of shapes, like a spherical, rod shape, and even they can be oval or disc shaped. And it shows different shapes when activating and inactivated states. And it contains a cell membrane, a microtubules, and cytoplasm. In the cell membrane of the platelet is around 6 nanometer in thick, and the cell membrane invaginate into the cell forms the open canalicular system. That is the most important phenomenon in platelet. That means it shows open canalicular system. That is a delicate tunnel system through which the platelet granules extrude their contents. And the cell membrane also contains lipids in the form of phospholipid, cholesterol, and glycolipid, carbohydrates as glycocalyx and glycoprotein and proteins. And the glycoprotein and phospholipids are more important. And the thing which we have to remember is the open canalicular system. And the microtubule, it seen below the cell membrane, and they are made up of polymerized protein known as tubulin. And these tubules provide structural support of the inactivated platelet to maintain the disc-like shape. The tubulin maintain the structure of the platelet. So that cells, apparatus, plasmic reticulum, mitochondria, microtubule, and all. And also the cell membrane contains chemical substances which activates or inactivates the platelets. The normal count of platelets are around 250,000 per cubic milliliter, and it varies between 2 to 4 lakh or 4 million cells per cubic millimeter of blood. And the properties, that is 3A, that is adhesion and agglutination. Adhesion, aggregation, and agglutination. So adhesiveness. Adhesiveness is property of sticking to a surface. If the